About the first update that is a disappointment. This one will be a fail, I think, doing it the way I wanted. So here's the shape of the wing, and I will show you the problem. The shape came out great. It looks like it's going to be a good wing. It's an asymmetrical wing. Now that alone I could deal with. I could technically make that work. The problem is, before I get into this, I'll show you a few different things. And now I will show you the body of the aircraft that was going to be. Now you can see this was intended to be one side of this. And I'm talking a big wingspan. I was going to make a glider, basically a powered glider. So my original plan was to cut this down the middle, pretty much, and make a cut. And it looked like that was going to be a doable thing. I could still technically do it, but I need access to a bandsaw. My roommate has a fair number of tools, but not a bandsaw. I don't know. I don't think he has a Sawzall either. And even if he did, it would be very difficult to put this in place without a workbench and clamp it up so that it actually holds position. So I'm going to show you the problem, and this is the essential problem. I cannot get deep enough into this with a Dremel. I was able to cut it. I thought it was just a carbon fiber shell on the exterior, and that would have made for an easy cut. If you look at this end, when I made my first cut, it was all just this cord foam. When I made my second cut, it appeared to be the same thing, all just this foam core. And then I got here, and I had a real hard time getting through there, and I discovered this pocket. Now, this is solid at the bottom, so there's a section here that's solid carbon fiber. Much like a wing, it's got hollow sections, and then it's got sections that are filled in with this foam, and then it also has sections that are solid carbon, making it difficult to cut through. Now, that being said, I haven't totally given up on this yet. Eventually, this will be the wing for a aircraft, but right now, it's not today. I was going to finish this today, but it looks like this is no longer a feasible option. So, just to give you guys an idea of what it is that I'm working with here, I'm going to show you some quick measurements. As usual, I will give you an idea where things are at. Okay, so we're looking just about 19.5 inches. And then the wing, you're looking at on 1/2 of this wing. Yeah, sorry, this is really awkward to do one-handed, but I'll manage. We're looking at 14. So the idea was it's basically going to be a 21 with this little overhang. We're looking at about a 21-inch body length from tip to stern, not counting the engine. And don't forget that's going to add another inch or so. So we're looking right around 22 inches. And the wing, as you could see, is at 14 inches, which means the body would be 22. Sorry, did I say 14? I meant 16. The body would be 42, and we would be looking at a 32-inch wingspan. That is huge, but when you look at a glider, that's not bad proportions for a glider. So unfortunately, this project has been put on hold. Now, I do have 2 more donators here of this stock, but this is the exact same hockey stick. My roommate worked at an arena for a time, and I asked him to bring me home as many of these as he could because they make awesome projects. At the time, I was actually building a sailboat and was thinking about using the carbon off it for a sailboat. The problem is it's really not the right shape, and it just seemed like it was more trouble than it was worth, and it would be easier to make a buck and build one from scratch than it would to build one out of this. But because I build a lot of projects, I assumed that I might use the material. Now, I could make an identical wing to this out of one of these, which isn't hard to do. You can see I didn't have to cut that much off it. In fact, here, it's stock width, and I just narrowed it down from there. The back edge is actually the leading edge, and the leading edge is actually untouched. Okay, so I did all my trimming off the one edge. Now, that worked really well to give me the shape that I wanted, and I'll just line this up so you can see roughly what portion of this has been used. And you look at it and go, oh, that's not right. But it's because going the other direction. It's printed the other way. So if I set this up the same, you can see what part I've used. And we've got a pattern like this. I did cut off the bottom, so what you're actually looking at is just this top from where this line ends. That's what I did. So it made it a very, very easy job because all I literally had to do was cut one line and the line was already formed for me. Now, this piece was generated when I originally cut the carbon fiber keel for my sailboat over there under the Canada flag. So in all that, working with these so far, I've even cut shafts off them and all that. They were always hollow or foam core. And this might not seem like a big deal, but I can only get about a ½ inch into it with the Dremel, which means if I do what I had planned and cut down this edge and then cut down this edge, I'm nowhere near through it. I had known that would be the case, but I had assumed it would be all foam core inside, which means I could just make up a hot wire setup and cut it with a hot wire. That was my plan to get it through, and I was going to film that and show you guys the whole setup, but I don't see the point in that now because it's not going to work. There are too many, even one of these hardened carbon sections is not going to be cut with a hot wire, and to be honest, would be kind of dangerous to do so. I don't want to be lighting it on fire. So I'm not sure what to do about that now. I can't get the Dremel down in here to cut this section, and it goes pretty deep down. I mean, it's the depth of my finger to the second knuckle. And it was even deeper. So that and the fact that I do not know if there's another one of these chambers in this blade. I'm guessing there are chambers throughout the blade. And that's part of the reason for its strength. So I got no choice but to sideline this. I could use the whole thing. The problem is it's heavy compared to what my needs are for weight. It's not going to work. It's just too heavy. And if it is going to be that heavy, I have to rethink my tail. I have to rethink my engine setup, and it would need a more expensive engine setup. I would probably end up having to run it on 3S just to be able to get it in the air. I don't want to have to do that. My plan was to have this be a 2 to 3S plane, which means I need to be light enough on the light end that 2S will do the job. That means we're talking 7.4 volts, probably at most a 10 amp burst discharge with a 12 or 14 amp ESC. That would be just great. That being said, you know, I really want to do this, and I'm excited about it. I've got a good shaft that came off of a fishing rod, and these are great for this. And I got my tail cut. I got the plan laid out for where I would want everything to sit. Got everything cut. Tested my engine fit, all that stuff. And when I knew that that was correct and I had the body ready to accept a wing, I started working on the wing. That being said, this is not the end to this project, but it's got me looking for another wing I can use in the meantime. And I'll use this as a template and then make a pair of wings. So until I get some more material, either way, I'm at a stop, which is unfortunate. But when something like this comes up in a project, guys, especially if you're an engineer and you really want to do it right and you're making a home project, it's all the same. I mean, if you're an uneducated engineer and you just want to do your thing, that's great. There's nothing wrong with that. But a real engineer considers the realities. And what I mean by that is if you don't know what you're doing, you might just say, hey, this is light. I can do this. Build a second one, put it on, and try to fly it. Only problem is all I've got is 1S motors and power supplies for batteries. Well, that's not enough. I had planned on using 2S for this. But if you use 2 wings of this weight and size, you are not, I repeat, not going to be able to fly this on a single cell battery ever. And you're certainly not going to be able to fly it on 2S without a really high-end 2S battery. That is a possibility. But at that point, you may as well just use a cheap 3S and make your setup 3S compatible. But doing that means a more expensive setup. If I can't fly it on 2S because it's just too darn heavy, that's bad. In addition, this is an asymmetrical wing. Now, I was originally going to cut it on the bottom side of one and on the top side of the other to make it 2 asymmetrical wings. No, I was actually going to split it right down the middle and then cover the bottom, and I would have two proper wing foils there. They wouldn't have the perfect incident, the moment of lift wouldn't be exactly where I wanted it, but I could deal with that. I could shave it, I could shape it to make it what I want. What I can't do is flip this, which means, because it's cut along the backside as well, which means, and even if it wasn't, I still wouldn't have the shape of the lift body exactly the way I want it. But like I said, that is the easy part. That I can deal with. But consider the following. If I make an asymmetrical wing, I can't study some aerodynamics, and you'll find that an asymmetrical wing, when it's level, won't create any lift. And if I put it like this, it'll create lift. But when the aircraft flies, the wing will have to fly like this to continue to make lift. If it drops to level, we won't be generating much lift at all. And for a glider, that sucks. You'll need a lot of power to keep a wing this big in the air. That is the problem. That is essentially the issue. So let's say I make this a flat wing like I had intended. Don't forget I was going to cut it in half, so it wouldn't be an asymmetrical wing anymore. Instead, I would have two wings that are symmetrical, but we're talking about the airfoil here. An asymmetrical airfoil means that on the left side and on the right side, as you're viewing it now, they are exactly the same shape. Okay, well, if you look at a wing, that's not how it should be. A flat bottom, so when I cut this down the middle, you could see that it would have a nice arced top and a flat bottom if I cut it straight off and make it a nice flat. Okay, well, that was my plan. That would have given it the proper shape of a wing and made it half the weight, which would have meant this would have been the weight of my entire wing. Okay, I could manage that. I could fly that on 2S, I'm pretty sure. And if I needed to, I could shorten this wing, and I pretty much was gonna. It'll end up being about this long, guys. Because as you saw, it's a bit big. It's 14 inches. And if I'm going to make this airplane not a glider, I need to account for that. So when you change your wing, you change your design. As an engineer, I look at this and go, okay, this is going to be great. I'm going to have two carbon fiber wings. And then I get to this point and realize I can't just cut it in half. I don't have the tools to do it. And if I had the money, I could go and buy myself a saw table with a bandsaw on it and cut this sucker up in no time. If I had a proper workbench, I could buy one of those and clamp it properly and cut it in half. And I just don't have the money. I'd have to go spend $1,000 in tools basically right now to be able to do this, and I don't have that. Plus, I try to keep it so that on my channel you're learning how to build things really cheap, and I don't want to be recommending to you guys that you go buy $1,000 worth of tools. So for all those reasons, this is no longer suitable for the build I'm doing. And the reason is, A, I want it to be capable of flying on 2S. I was hoping to have a glider. Out of that, not so much, but I wanted it to have good glide ability. I wanted it to fly very well on low throttle and be a good slow flyer, which means I pretty much want a glider. I either want a glider or a stall plane, like the little plane I built, and that is part of the problem. I want to build a Cub, but I was going to use this stuff, which means I'm going to have the exact same problem with my next build if I choose to use this material. If you don't have the tools to cut these properly, I don't recommend using them because it's going to be a nightmare. In fact, it already kind of has been with this to try and do this with a Dremel. And you can see why. So, you know, I'm going to address this, and I'm not the type to give up. This will be a plane one day. Unfortunately, it's not this day. And so I'm going to cut this one. It's getting pretty long, but I wanted to have a quick talk with you guys about the types of things you can use to make your wings and the kind of things that are going to come up when you're engineering. I mean, you always have to make your engineering realistic, and a lot of engineers make the mistake of making their designs kind of pie in the sky. They make them theoretical, but not practical. Just because the theory works doesn't mean you can build it. Doesn't mean it's going to be economical to build. When you design a modern aircraft, you have to think not only about building it, but making it economical to build, making it so that it's not going to be the most expensive aircraft on the market if you want people to be able to buy it in any kind of number. In this case, I want people to be able to build it themselves which means, you know, recommending to you guys $1,000 worth of tools to start your build is just out of the question. In fact, it's out of the question for me. I'm on social assistance. I cannot afford it. So I'm going to be making the wing out of something else. It was great for the carbon fiber keel, and I highly recommend it. But in the end, you know, that really wasn't working. I could still use this for some stuff. I will. We're going to cover that later. But in the end, I've got to find some other wing substitute for this. Now, the trick is, I don't just want to use the flimsy plastic that I have been using, but I could use this stuff. I had a couple of thoughts on it, and I could make a biplane out of it, essentially. And that's what I'm going to do. See these guys? They make amazing VGs. So what I'm going to do is I'm going to cut this out here along this edge, right down that seam, right in the middle, along the bottom and along the top, all the way across, and then fold it out to this seam and attach it on this seam. So I'll have lift along the body. It'll be a big wing because these will be the tips. And I'm going to snip this part off and use these little up as tweaks as my... This is a nice angle here. It's not a 90 degree, as you can see. It's more like a 45 degree, and that is perfect for making my little wingtip VGs that I like to make. So I also have similar ones on the tail, so that'll fit right in with the design. And I can basically make that one wing. When I do that, its total length, if we were to just take a look at this, I'll line this up along the back side so that, and then we just roll it over and roll it over again. And you can see I got a much bigger wing here. This would be a much bigger wing than that 28 inches, you might think. But no, this is half the wing. So this was 16. It would have been 32 inches. That's looking like it's going to be about 26 to 28 inches. And of course, we can just take these and add these lengths together. And we have another wing. So I'm not going to do that. It's already a 17-minute video. I'm actually just going to can this one because the point of this video is to talk about the materials you're going to use and whether they're appropriate for what you want to do. And you might think, because this is carbon fiber, it's automatic. It's a no-brainer. It's going to be light enough. The reality is it's not, because it's too big, for one. The wing I want to make is too big. And the total will be way too heavy. I would do better off. It'll glide better with a smaller wing that's not asymmetrical, rather than having this wing at this length. And the reason is it's asymmetrical, which means it's really not generating much lift. And for a body that's not generating much lift, it's generating a lot of weight. That's unacceptable, guys. So this is a better material, even though it looks like crap. And I will not have the pretty, sexy, all-carbon machine that I wanted, unless I'm willing to accept two things. One, it's got to be an asymmetrical airfoil, which means it makes almost no lift. What's that good for? Believe it or not, what that's good for is a 3D flyer. And that is what I've decided to make out of this guy. It's going to be a 3D airplane. That's one option. I could go that route. But it would totally change the design of what I'm looking for. I want a slow flyer, not a 3D bullet. I'm flying outside with the neighbors' kids around. So I want to be really careful, and I don't want to have a huge wingspan. I do not want a 32-inch wingspan. I'm looking for a lot smaller than that, guys. 24 to 28. I could do 36 reasonably and realistically here, and it would be all right. But it would have to be a high-lift wing like a stall aircraft. And for that to happen, I really need to cut this in half. So I will look into it. I'll see if I can get a hold of the tools I need reasonably. And eventually I will make this into an aircraft. And because of that, because I know what I'm going to do with it, and I have it all planned out in my head, and it's going to be sick, I don't want to ruin it by finishing this build with something else. I'd rather use this. So I'm putting a build aside. Sometimes it's better to do that when you get caught up on something rather than totally redesigning it. I mean, if you're not in school, you're not under pressure, you're not turning it in as a project, what's the rush, man? Take your time, do it right. And in this case, yes, I could just make it 3S, but that means more expensive electronics. And as I said, I'm on welfare. It also means more expensive batteries, which means I got to engineer this within the limitations of economic reality. Well, I bring this series to attention because it's very much like designing a real aircraft. Oh, wait, it is a real aircraft. And in the end, all the same things apply. From economics to structural integrity to lift factors, all of this matters. So in the end, when you look at all of the individual components together, they have to make a well-engineered package. And if they don't, you're doing a shit job as an engineer, and I'd rather you just rethought it and did it right and took your time and made it perfect. There's too many engineers out there putting out shoddy work because it works theoretically. I could build one here that works theoretically, but it would be very expensive. It wouldn't be very efficient. I don't want that. Keith out.